There will be 4 free response questions on your AP exam. This video is modeled after FRQ number 4. It's about trigonometric and logarithmic equations. Let's pretend it's from the 2007 exam. If you appreciate this content, please give it a like. Here are the directions you will see on the AP exam for FRQ number 4. Pause the screen and give it a read. Part A. The functions g and h are given by these two expressions. A Part 1. Rewrite g of x as a single natural logarithm without negative exponents in any part of the expression. Your result should be of the form natural log of expression. One of our log rules says that c times the natural log of a can be rewritten as natural log of a to the c power. So let's take this 6 and move it to the exponent. So now we have this, but there's another log rule that says the natural log of a minus the natural log of b can be written as the single natural log of a over b. So g of x can be written as a single natural log of x minus 1 to the 6th power divided by x plus 3. And that's it. We have a single log with no negative exponents. A Part 2. Rewrite h of x as an expression in which sin x appears and no other trigonometric functions are involved. The sine squared part is already good, but we need to do something about the tangent squared part. We know that tangent is sine over cosine, so let's split this up as sine squared x over cosine squared x. Multiplying straight across, we have h of x equals sine to the 4th power of x over cosine squared. Remember, we are trying to rewrite h of x as an expression in which only sine x appears. The numerator is good, but somehow we need to rewrite the denominator with a sine function instead of a cosine. The following formula is called an identity. This is the most important identity that I need you to memorize. Sine squared x plus cosine squared x is equal to 1. Just memorize that. So I see cosine squared right here, and here's cosine squared. Let's get cosine squared by itself by subtracting sine squared from both sides. That will leave cosine squared x is equal to 1 minus sine squared x. This is something that we can substitute for cosine squared. And oh look, it involves sine. So h of x is equal to sine to the 4th power of x divided by 1 minus sine squared x. And that's it. We have rewritten h of x as an expression in which sine x appears and no other trig functions are involved. By the way, you don't need to write down what I wrote in blue. This was just for instructional purposes. Part B. The functions j and k are given by these expressions. B Part 1. Solve j of x equals 3 to the 2/5 power for values of x in the domain of j. Setting j of x equal to 3 to the 2/5 power, we have this equation. It will be simpler if we don't have a fraction involved. So let's multiply both sides of the equation by the denominator. On the left side, the denominator will cancel out. On the right-hand side, we have like bases that are being multiplied. So we end up adding the exponents. So we're going to have to do 2/5 plus negative 1, which is really just 2/5 minus 1. And 1 is the same as 5 over 5. 2/5 minus 5/5 is negative 3/5. So that will be the new exponent after we multiply these together and add the exponents. Also, when you raise a power to a power, you multiply. So 3 to the x squared is the same thing as 3 to the 2x. So now we have 3 to the 2x times 3 to the 1/5 power is equal to 3 to the negative 3/5 power. On the left side, we once again have like bases. When you multiply two expressions with like bases, you keep the common base and you add the exponents. So this part will become 3 to the 2x plus 1/5 power. And this is all equal to 3 to the negative 3/5 power. At this point, both sides of the equation have the same base. Therefore, the only way these expressions will be equal is if the exponents are also equal. So 2x plus 1/5 must equal negative 3/5. Let's get the 2x by itself by subtracting 1/5 from both sides. Negative 3/5 minus 1/5 is negative 4/5. Finally, we can get x by itself by dividing both sides by 2. So we will have x is equal to negative 4 over 10. When you divide a fraction by a number, you end up multiplying the denominator by whatever you're dividing by. So negative 4/10. Of course, this will reduce to negative 2/5. So that's it for B part 1. B part 2. Solve k of x equals pi over 12 for values of x in the domain of k. Setting k of x equal to pi over 12 gives us this. We just need to solve this equation for x. Let's start by multiplying both sides of the equation by 6. On the left side, the 6's will cancel each other out. On the right hand side, we have 6 pi over 12, which reduces to pi over 2. Sine and arcsine are inverse functions, so you can cancel out arcsine by taking the sine of both sides of the equation. On the left side, that will leave behind the pi x minus 2. What is the sine of pi over 2? Pi over 2 radians is right here on the unit circle, and the coordinates of this point are 0, 1. Sine theta is equal to the y value on the unit circle, so the sine of pi over 2 is 1. Adding 2 to both sides gives us pi x is equal to 3, and dividing both sides by pi leaves x is equal to 3 over pi. And that's it for B part 2. Part C. The function m is given by m of x equals this expression. Find all input values in the domain of m that yield an output value of 0. Finding the input values that yield an output value of 0 is a long way of saying solve m of x equals 0. Setting m of x equal to 0 gives us this. Next, let's use the log property that allows us to take this 1/2 and move it to the exponent. Next, let's move this expression to the other side of the equation. We are adding log base 7 of 2x plus 8 to the 1/2 power to both sides. Now we have this. We can cancel out the log base 7 by dropping a base 7 on both sides of the equation. Both log base 7's cancel out, so we are left with x is equal to 2x plus 8 to the 1/2 power. Next, we can get rid of this 1/2 power by squaring both sides of the equation. So on the left side, we're going to have x squared. On the right-hand side, when you raise a power to another power, you multiply. And 1/2 times 2 is 1. Basically, these cancel each other out. We are left with x squared is equal to 2x plus 8. Let's get 0 on one side by subtracting 2x and 8 from both sides of this equation. We get x squared minus 2x minus 8 is equal to 0. If we're lucky, this is factorable. Otherwise, we have to use the quadratic formula. X squared will factor as x times x, and 8 will factor as 2 times 4. Inner plus outer must equal the middle. So we need an inner of positive 2x and an outer of negative 4x. Also, positive 2 times negative 4 does make negative 8. So we have factored correctly. Next, using the zero product property, we set each one of these factors equal to 0. So setting x plus 2 equal to 0 and x minus 4 equal to 0 gives us x is equal to negative 2 and x is equal to 4. But we must be careful to check for extraneous solutions. You cannot take the log of 0 or any negative number. So you need to make sure that plugging either of these back into the original equation does not have you taking the log of a negative number. Because of this expression, with the log of just plain x, x cannot be any negative number. So this is extraneous. This is out. 4 is fine. So x equals 4 is the only solution to this equation. Hey guys, don't forget to like and subscribe. But also, if you found this video helpful, there's a lot more where that came from. You can click the upper link, which will take you to the whole unit playlist, or you can click the lower link, which will take you to the next video in the playlist. See you there.